Hi class, in lesson 1.3 we will be investigating prime and composite numbers. Learning targets for today, we will distinguish between prime and composite numbers and identify and use the multiplicative identity. Keywords to look for in 1.3 are prime and composite numbers and multiplicative identity. If we look at the lesson introduction for today, just a little bit of background knowledge heading into 1.3, you may have heard that during the time of Columbus, many people believed that the earth was flat. However, some historians think that that is a misconception. These historians do make a good point. Greek mathematician, geographer, and astronomer Eratosthenes has been credited as the first person to calculate the circumference of the earth. He made this calculation roughly around 240 BCE, thousands of years before Columbus's time. If you remember, circumference is the distance around a circle. Therefore, even back then, people assumed that the earth was round. Let's take a look at problem 1 on page 32, the game. A sieve is an old tool that is used to separate small particles from larger particles and is usually a box with a screen for a bottom that allows the smaller pieces to fall through. The sieve of Eratosthenes screens out all of the composite numbers and leaves only the prime numbers. Prime numbers are numbers greater than 1 with exactly two distinct factors, 1 and the number itself. Composite numbers are numbers that have more than two distinct factors. You and your partner will solve the sieve of Eratosthenes to determine all of the prime numbers up to 100. The figure shows the first 100 numbers written in numerical order in an array. What I would like you and your group members to do is follow the step-by-step directions starting with number 1. You're going to start by putting a square around the number 1 because it is not a prime or composite number. From there, follow steps 2 through 5, and I'm going to give you a little hint. You should have 25 prime numbers that are listed after you are done. So go ahead and complete the rest of the steps with your group members. Here is what your sieve should look like after you are done following all 5 of the steps listed down here. On number 5 would be all of those 25 prime numbers that we have up to 100. So go ahead and make sure that you check over all of those numbers to make sure that they are correct. If we turn to the top of page 33, I would like you to answer number 6 and number 7 with your group members. For number 6, only one even number is prime. 2 is going to be your only even prime number. For number 7, no, it is not possible because every even number greater than 2 is going to be divisible by 2 or has a factor, or has 2 as a factor, so that's going to make it a composite number. Let's skip number 8 and take a look at number 9 and 10. Please answer those 2 questions at the bottom of page 33 with your group members. If we look at number 9, no, some odd numbers do have factors other than 1 in themselves. Just as an example, 9 has the factors of 1, 3, and 9. Therefore, it is not a prime number. If you came up with other examples, that's great. For number 10, the prime numbers from the area models that you created were 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. These numbers always have only one area model because the only factors of a prime number are the number 1 and the number itself. There are no other ways to make other area models for those numbers. Let's turn to page 34 and finish up lesson 1.3 with the talk the talk activity. If we take a look at the bullet points listed here, the number 1 is neither prime nor composite. Also, the number 1 is a factor of every number. The number 1 is called the multiplicative identity. The multiplicative identity is the number 1. When it is multiplied by a second number, the product is the second number. An example here could be 1 times 5 is equal to 5. To finish up for today, I would like you to answer numbers 1 through 3 with your group members. If we take a look at number 1, the number 1 is not prime because it does not have two distinct factors, 1 and itself. It is not composite because it does not have more than two factors. 1 has only itself as a factor, so it is neither prime nor composite. Very important that you understand that. For number 2, all prime numbers have exactly two distinct factors, 1 and the number itself. And for number 3, all composite numbers have more than two distinct factors. That will be it for lesson 1.3 on prime and composite numbers. Please let me know if you have any questions. Thanks.